Okay, I'll start. So thank you for coming again. This is Python for Neuroimaging for Beginners, the second session. Again, this is for people who have no engineering background and have an interest in learning Python to apply in neuroimaging. And today we will focus on array. Again, to highlight the learning process for Python, you have to solve a problem, either by searching the web or asking others, and you have to solve another. This way you learn it, and in that learning, you don't need to memorize anything. And learning from watching is very minimal, so take your time and solve a problem if you can. So last time, just quick recap, we talked about data types, integer, floats, and string. We've seen that we could merge different items into a list on another variable, and we could select out the items that we want by something called indexing or slicing. We also used for loop, and we imported libraries, and we tried running a Python script, and we also got input from the command line into the Python script. Okay, there are many more Python basics than this, but we just skip them in order to focus more time in your imaging. That's what we want. So today we're focusing array, and we'll be using libraries called NumPy and matplotlib library, and Barbell or Barbell using Jupyter Notebook. So if you have your Anaconda installed, so if you will have Anaconda Navigator like this, then you will see Jupyter Notebook here. If you click on Launch button, you will see this page in your Chrome or Safari. Then you can click on the New button and click on Python 3. If you have any connect and connected through partners, Jupyter partners, Jupyter Hub, then you can just connect to it and log in and click on New and Python 3 again. Okay, and if you're using your own laptop, it'd be nice if you can download a example Nifty file from the website, and then download it and unzip it so you can later use that. I'll take a screenshot of this. All right, so back to array. What do you think this is? I'd probably say it's an apple. I see top of an apple, I see apple tab, and there's a leaf coming out of the tab, right? That's what I think it is. But if I zoom into a part of it, and again, I start to see boundaries around it. Okay, I see there's a boundaries, and again, if I zoom in again, I start to see boxes with distinct brightness. So we call this each voxel a pixel, and each pixel has a value that represents brightness. So the box here is quite bright, so it has a value of high number, and the dark boxes has low number. Okay, so pixel has a value that represents the brightness. Let's remove the background here. So you see what I'm trying to highlight. They are numbers arranged in an array. Okay, they are literally a matrix. Now, what do you see? Is an apple, but it's also numbers arranged in an array. All right, quite dark here, so lower number would be here. Quite bright, so a little bit higher numbers around here, and probably mid number between them. Okay, right. So what do you think this is? Espresso cup, right? But it's a number in an array. So high is very bright here, so a higher number, and coffee a little bit dark, so it's a low number. Okay, the same logic applies to MRI image. It's an array filled with numbers. So white matter is quite bright, so it has higher numbers. Ventricles and gray matter is darker, so it has lower numbers packed in their array, in their locations. Okay, and skull is quite bright here, so probably have very high number here. And outside the brain is very, very dark, so the number will be very close to 0 or 0, right? Quite simple. So now you know this is an array, so it is a 2D array. that slice 2D array, and the next slice is the 2D array as well. And this is just a bunch of 2D arrays. So a bunch of 2D arrays concatenated together is three-dimensional matrix, three-dimensional array. Okay, now you understand the structure. So it's quite simple. So since they are 3D, there are still boxes, but we call them voxel rather than a pixel, and they still have the values that represent the brightness in them. Okay. So there is a type of MRI, so-called functional MRI, which looks into changes of brain activation over time. So in order to do this, they take images of the whole brain many times. So they take whole brain image, and they take another image. After a few seconds, they take another image, and in this way, they look at the changes of the brain. It looks very difficult to understand, but if you think back, whole brain is a 3D array, and another brain is a 3D array. They are arrays. 3D arrays bunched together, 4D array. Okay. Same thing applies to diffusion image. We take B0 image, and we take many other volumes with diffusion weighting in different directions. Okay, so this image, whole brain, is a 3D array, 3D array, 3D array, and 4D array. Okay, again, they are just bunch of numbers arranged in array. Many 3D matrices, so 4D matrix. To be honest, it took me a while to understand this simple concept. When I saw brain, I thought it was like output of very difficult super science, graphs or something. But it is, but they are they are a simple array, simple numbers arranged in an array. Okay. So that's why we are focusing on array today. So playing around with small array can help you learn how to manipulate array, therefore how to use it, how to use and how to load your images and apply other tools to it. Okay, and let's open up Jupyter Notebook and follow along what I do. So this is the data that you should get if you are using your own laptop. Download the nifty images and unzip them. Okay, first we will have to import, I'll have to show you from here. Okay, this is the Jupyter Notebook that you see. And you click on the new button and click on Python 3. Or if you have your own environment, which we will not cover today, click that, or Python 3. Then this new notebook in a new window will be created called Untitled. Okay. First, what we have to do is import the libraries. So just type import numpy as np. We've done that last time, and we're going to import other library called matplotlib pyplot as prt. So this is importing this thing as something called prt. And I told you there's not many things to memorize, but this is something that you have to memorize. So without this, graphs will not be shown on Jupyter Notebook, so just put them in anyway. And you either click on Run button to run this cell. So it says run, and it finished running. Or you can do Shift and Enter to run that. Go to the cell and Shift and Enter. Okay. Right. Next, let's create an array. Let's create an array using NumPy. So let's create an array called A equals np.array, open parentheses and open brackets again. Then I'll write numbers. Okay, and then shift enter. Then nothing comes up because you're just assigning something to A. And just click on, just try typing A and shift enter. It returns what your A is now. So your A is a full number array, which has 1, 2, 3, 4, 5, 6. Okay, let's try creating an array in different shape. A equals np array, open parenthesis, and then brackets. And then we want to, when we want to create different rows, add another brackets to it. So first row will be 1 and 0, and comma, and you can press enter, or you don't have to change the line, but I tend to do it because it's easier to see. And align them and open brackets 0 and 1. Okay, and shift enter, and let's see what A is. A is an array, has a shape of a square, right? 1, 0 and 0, 1. Okay, let's look at the shape of the array by using a dot shape. Yeah, it returns the shape of an array. Let's plot them. It's difficult to see them like this. I tend to plot them every time like this. So let's simply plot them by using plt.imshow open parenthesis and A. And we can add this little color bar next to it by just typing plt.color bar open parenthesis and close it. Yeah, so yellow is 1 and purple. The dark color is 0. So 1, 0, 0, 1, 1, 0, 0, 1. Okay, let's try something else. Let's try creating, copy that. Let's try creating another array with extra laws with this. So A is this now. Let's plot them. Yep, 1, 1, 1, 0, 2, 0, 1, 1, 1, 0, 0, 2. Okay, you can plot them. I have a habit of plotting everything so I can understand it easier. So it might be helpful to plot everything in the beginning for you as well. We can try transposing an array. T. So what was A? A was this, and when you transpose it, just by adding dot capital T, you can make it like this. All right. Again, let's plot them. PRT, I'm show A. Don't want to color this time. Just plot them like this. All right. I want to plot them to plt.imshow open bracket, open parenthesis, like this. Okay. Transposing. Very easy. All right. The sizes look a little bit different, but ignore that at the moment because we are using the simplest form of plotting, so they are not controlling for the size. So let's ignore them. Okay. Now you can create an array by typing, but you can also create arrays in different shapes filled with something. So you can create different arrays filled with zeros. You can just tell them the shape of the array that you want to create. And you can also create an array filled with ones. And you can also create arrays with the set of numbers between a range. Okay, let's try this. So let's try np.zeros parenthesis 10. It creates an array with 10 items in it. Let's try 20. Oh, by the way, if you don't want to go down by doing shift enter, you can do control enter on a cell. Then the active cursor doesn't go down. Control enter, shift enter. See the difference? Okay. What if I want to try 2 by 2 array filled with zeros? Then you open another parenthesis and 2 by 2. Close it. Quite simple. Can do 5 to, yeah. Let's create something with ones, and same logic here. You can create something 10 by 2. Okay. Linear space, NP, lin space. Between from 0 to 5, I want to create 10 items. All right. From 0 to 5, create 10 items. Try something else. 7, 4. Okay, 4 items from 0 to 7. All right. Very simple. Okay, let's go to the next one. So we can look at the, we can reshape the arrays into the shape that we want. Okay, A was this, or you can create NP zeros 5, 5. So it's A is a array 5 by 5 filled with 0. What if I want, let's shape, try looking at the shape. So it's 5, 5, 9. Now I want that the same array in a different shape. I do A dot reshape. I want to make it 25 by 1. Okay, or 1 by 25. Let's try again. You can create a numbers in a series by using np arrange, then do 9. So it creates from 0 to 9 numbers. Bear in mind it starts from 0 again. Okay, from 0 we create 9 numbers. We can reshape them. Reshape into 3, 3. Okay, A looked like this in the beginning, but then they're reshaped into 3 by 3. Very simple. Okay, create another random array. I'll do A, np arrange 8. A looks like this, and I want to reshape into 2 by 4. A looks like this. Okay, we can do array operations. Let's A plus 1. Let's do A plus 1. A was this, and A plus 1 is, yeah, it adds 1 to every items. Is simple. You can do -1. You can do ×2. Okay, you can do divide by 2. All right, array operations, simple. Okay, you can also find the maximum by doing max. So maximum in the array was 7. You can also do minimum. And you can also do average by doing mean. You can check standard deviations. Okay. All right, there are a bunch of other things that you can do. We are just sweeping through them. And okay, you know what this is now. Arrange, create a number from 0, 25 numbers, and then we want to reshape them into 5, 5. We can look at the shape of it. And this is index and slicing again that we did on the first session. So it's selecting the items that we want, right? A equals np arrange 25, create 25 numbers from 0, and we want to reshape it into 5 by 5. Now let's look at what A is. Yep, 25 numbers. Let's look at the shape of it. 5, 5. What do you think this will do? 0, comma, and then colon. Let's see what it does. It's returning 0, 1, 2, 3, 4. So 0, 1, 3, 4 is here, right? So on the first row, return everything. Okay, let's try this. 1 column. So on the second row, return everything. Then how do you grab columns here? Yes, column first and then do 0. Then 0, 5, 10, 15, 20, which is the first column. Okay? So in order to get everything in a row or in a column, use a column. It can also use slicing like this. Yep, getting 12, 13, 17, 18 here. Okay, let's plot them to make it easier. PLT, I am show. I'm going to plot A first, what this is like. And I'm going to plot, I'm going to copy this, plot, I am show, plot this. Okay, is grabbing something inside it. But you see the intensities? It is difficult to see which part this is coming from here. So in a plot, you can give where to start your contrast from. So minimum 0, Bmax 25. You can add something like this in order to make your graph consistent in colorless. So this part coming from around here, okay? Yeah, just try doing something in your own Jupyter notebook, play around it, and I'll show you how to draw 2 graphs together now. When we change values or do something to the array, we want to compare 2 items together. So when we were drawing a single graph, like here, we use PLT IMShow, but now we have to use something different. So I'm creating figure and axis from PLT subplots. And I'm gonna state how many columns I want to create. Columns 2, I wanna create 2 columns. And for the first axis, I want to plot A. And for the second axis, I want to plot whatever that I select from X. A. Yeah. Okay, let's just try this. All right, this is A, and this is what we selected from A. Okay, and again, we can add something like this to make the graph color consistent. Yeah. Okay, you can now plot 2 axes together. Okay, now let's try values in a matrix. So A looks like this. What if we want to change values around here? Or what if we want to change value of everything? Let's do this. Okay, A, so again, create 25 numbers from 0 and then reshape into 5 and 5. And A looks like this. Yeah. Let's change the third item from the row and then third item from the column. A, 2, 2, because the Python numbering starts from 0. Let's do this. So you are assigning a new value to a place in an array. Let's see what it is. See, you've changed 12 into 10, 100. Okay, let's plot them now. So copy the graph that you created, paste it here. Let's define what A is. A was NP arrange 25 numbers from 0, and you wanted to reshape into 5, 5, 5. Okay, you're going to plot that here, and then you want to change the values of the third item in the law, the third item in the columns into 100, and you will plot them again. Simple. Yeah, let's do them. Okay, now you can visualize what you have changed. So you have changed the value here, which was 2, 2, the third item here, the third item here, which was here, into 100. All right, let's copy that. Oh, let's do it from the beginning. So A looks like this now. What if I do this? A colon 3 equals MP array 30, 40, 50, 60, 70. Try this. PLT, I am show A. A looks like this now. So you're changing every raw in the fourth column into 30, 40, 50, 60, 70. Okay, let's plot them together. So A was 25 numbers from 0. We've reshaped them into 5, 5, and plot them on the left graph. And we updated part of it by setting second into 100, and every row, the third column, into 30, 40, 50, 60, 70. Yes. Okay. We can also select by conditional statement, like let's try creating a random array using NumPy module. Let's do A equal np random dot random, open brackets, 3, 3. What do you think this will do? You can just guess. So random, so it's creating a random array in the shape of 3 by 3. Let's try seeing that. Yeah, let's visualize it. Looks like this. What if I run this again? Should it change, right? Because it's random. Okay. It's easier to see if I put them here. Okay, try running that. Changes every time since it's random. Okay, let's add a color bar to it. So the range of items in A array is between 0 and 1. Every time is between 0 and 1 for this command. Okay, so I look at the array, it looks like this. What if I do this? A greater than 0.5. It returns true or false for each item, whether each item is bigger than 0.5. All right, we can use this to select an array like this. A, open brackets, A greater than 0.05. What do you think this will do? I'll just try to run this. Then it just returns the value for the true items for this condition, which is 0.9 greater than 0.5, okay? And I can change those values into something else, like this. Now look at what A is. It looks like this. Okay? You can grab items using conditions like this. All right. Try plotting 2 of them together using this. So A was a random array, right? MP random dot random 3 by 3, and I wanted to create a figure, 2 figures actually. MP PLT subplots creates columns with 2 figures, and for the first figure, I'd like to plot what A is, and then I want to do something to A, which was change value which are greater than 0.5 into 10. Then I want to plot this updated A into second axis. All right. So it has, let's add callable to it. See, I don't know how to add callable. Yes, I'll search how to add callable. Figure, method library, go to the first one, second one, third one, and just read through them. Fig.callable, you have to give x. Fig.callable, you have to add x. Do the same. Fig.callable x to give x. Mappable, maybe A. Okay, I'll search how to do this and show you later. Let's pause because we have slides to go through. Yeah, now you can select the condition using conditions. Okay, we can stack the arrays like this. So original array looks like this. We can stack them horizontally. We can stack them vertically using np hstack or vstack. Try running that. I'll just pause this. And we can also use another condition statement using np where. So say A is a random array, which looks like this. We can select items using conditions, say A greater than 0.5. You want to change this into another value if it's greater than 0.5 into 20. And if it's not greater than 0.5, change into 0. Then it creates a new array following the conditions. Okay, it creates 20 for items greater than 0.5, makes 0 for items not greater than 0.5. Okay, so condition goes here, if true, if false. You can also do something like this. You can create like normal distribution. It was too much array, so I added this to show you sigma 0.5. So you are literally creating a random Gaussian distribution using np normal. And mean of 0 and standard deviation of 0.5, and you are creating 100 items. Maybe it's just one more. Sorry. Oh, the Python version, some may act differently. Random normal, my bad. So it's random.normal, average of 0, and sigma of 0.5, create 100 items. So let's see what V is. Yep, bunch of items. Let's plot them. We can't plot them because it's a single line with I am sure. We can reshape them into 25 by 4. So it looks like this. And now we can have a look at histograms. of bin using how many bars do you want? 50. Yeah, it's approximately normal distribution. It should be. If I create 1,000 items, 1,000 now. Yep, it's more closer to normal distribution. I can change the number of bins into 100. Yep. Okay. We can do other scientific stuff to arrays. There are another module called Sideby. So Sideby has a bunch of other tools that you can think of. Has integral in it, optimization, interpolation, Fourier transformation, statistics as well. You can do other stuff in it. Okay, try checking out them. But here we are trying to understand how to manipulate arrays, how to plot them, and just to understand why they rotate and how to rotate them, how to change numbers in them, so we can understand the neuroimage format better. Okay, now we will load nifty images into it. We're not going to do much with it. We're just going to load it, and we will change a few values in it. We'll try plot them. That's exactly what we did previously with the small arrays. But the methods are the same. So try doing this. If you're using RGS server, you may have to add path to it because it has not been installed to your server. So if you're using your own laptop, do this, install Barbell. Then this will install Barbell from the web into your Python. We'll do something like this. If you're using RGS server, you will have to do something like this. Okay. After doing this, you will be able to import the library called Barbell. I will import Barbell as MB. Yeah, MB is ready. So I will load an image. I will load an example image. I also put example image in my home directory. So you can just type this if you're using RGS server. If you're using your own computer, you have to come back and you have to go back and download this from the web. Or you can just look at it and download it later and try later. Okay, Neuroimages is in/data PNL kcho /b0 example.py .nifty.gz, and I'm going to load them. Image equals, I'm going to load them using Barbell dot load and give the location of the image. Try typing ing. So it says the data type for this is nifty. Let's check the shape of it. It is an image shaped 128x, 128y, 70z. So it's like a box. Okay, it's a 3D matrix. Let's get the header. Header equals img get underscore header. Let's print header. Print header. So it has a bunch of information in the nifty files in the header. It says what dimension it is, what slice it starts, type of the data in it, and pixel dimensions and other stuff in it. But what we are interested in this time is an array. So let's get the array by doing data equals image dot get underscore f data. So this loads of data which was included in img image variable into data. Yeah. Now you have an array of data. See, it's difficult to see. So let's just look at the shape of it. As we've seen in image, The shape is 128 by 128 by 70. Again, let's plot them. So try plotting like this. This will not work because show plot a 2D matrix. Why don't we select the 2D matrix then? So I want to select from the raw everything, for the columns everything, and for the third dimension, which is Z slices, I'll get the first one. Yeah. Maybe get 20, maybe get 30, maybe 60. Okay, what if you do something else? So get everything in the last slice, get 20 here, 40, 60. Okay, let's do similar here, 20, 40, 60, 80. Yeah, now you get it. So let's work with the slice. Okay. You loaded them, and you've seen the shape, and you can also see the dimension of it. Try doing that, or just pause. And we can plot them like this. We just did. And we can plot selection of it like we did in the last time with the small array. Let's do this. pd show data. We are selecting from 30 to 90 on the x-axis, 30 to 90 on the y-axis, and on the z, we are selecting 60. Yep. Okay, let's practice again. Let's plot two graphs in a single figure. Do you remember? Fig and axis, PRT, subplots, encode 2, and then we'll plot to the first axis, dot show. We want to plot data, everything for the 60th slice. And for the second graph, we'd like to plot like sub-selection of it, 3 to 90, 30 to 90, and then figure it. Okay, so you're plotting two graphs with the brains now. Okay, so, we can also try doing this. This is drawing histograms, but drawing histograms is much faster using just a single line array. So if you look at what I mean is, if you look at the shape, it's very long array. Let's just look at the first one, 60th. It's not a single array, it's shaped like a square, but we have to make them into a single line first before drawing a histogram. So we can do something like this, ravel. Yeah, and then plot histogram. Let's add another bin. Oh, you can't add bins. Yeah. So by looking at this, in your array, in the 60th slice square, which is this, you have so many values, so many voxels with the value less than probably 100. You have so many values around here, which represent the voxels outside the brain. Okay. That was simple. And now we changed the values of the array before, and we can also change the values of the brain. Let's make a new underscore data equals 1 divided by the data. And I want to show them. I want to show new data, everything in the row and column, then 60th slice. Just show them now, like this. But it doesn't show much since the number is very small. We can do something like vmin 0 and vmax 0.01. And you see this image. Okay, try doing this. For this, I'll plot data. For this, I'll plot new data. Yeah. Okay, you can change value just like that. Or you can change value like data plus 20 and remove this. Vmin 0, vmax 1000, vmin 0, vmax 1000. Let's make them the same. Yeah, can't really tell by 20. Let's add 40. Let's add 60. How about add 600? Yeah, you start to see the differences. 300, 100. Yeah, now we see. You can do times 2. Yeah, times 3. Okay, times 5. You can divide them by 5. You can divide them by 2, like this. You can change values of the array. We could select part of the array, like using this slicing here. We can also change the parts of the array using the slicing. Let's try doing something like this. Okay. So here, new data is copied data. And in the new data, between 30th and 90th row and 30th and 90th column on the 60th slice, I want to change them into this value. Okay? You see? Just change this part. All right, try something like this. Change them to 10, 100. You can also do something like this, times 2, 3, 4. So you're just manipulating the array. All right. Now you understand the brain images that you get in Nifty format are literally numbers arranged in an array. So you can change the values, you can rotate them, you can plot them, you can plot density graph, histograms, and stuff like that. So they are on array. Okay, you can also save the edited array into a new file and then open them with FSO view or slice or something. You can do something like this. So save the new data using Barbell. And this is something that you have to give affine and give the affine of the image and give the file name. And new data is created here. And you can open it with FSO view if you have connections to it, but I don't have it now. So later you can go and check them. All right. Okay, okay, you can check something like this in FSO view. Now you understand the 3D volumes or 4D volumes are just concatenated arrays, numbers in array. So it's not it is super science, but it is in simple numbers. So you can manipulate them and you can understand them easier. There are many other modules and libraries are related with neuroimaging. There are so many: NePipe, NeTime, PoPi, NePipe. We are actually using many in PNL. So DiPi and NePipe in use, and Barbell we just used, and NeLearn is for machine learning, and MNE is for EEG, and there are so many MVPA analysis too. So, but now you know how to input images into those tools, since you know how to manipulate, how to load images. So now you can use them tools by looking them up. Okay, since our focus is in just learning basic Pythons, I just repeated many array manipulations together with you today. There, I've included 3 practicals at the end of it. So try doing that. And we can go through the practicals of this in the next session. Yeah, thank you.